The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
So one of our projects is to try to design a more precision irrigation system so that as the water is drying out, you trigger the solenoid valve to deliver the water. That will tell us at the end of the year, what's your crop per drop? How much more efficient can we be with our water because of our solar? So now you're changing that narrative from food versus energy to food because of the energy.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
We're here at the Solar Farms Summit. My guest today is Greg Barron-Gafford. He is a professor at the University of Arizona, and he's made a mark in the agrivoltaic space, doing lots of research on things you can do with solar farms besides just grow solar electrons. So welcome to the show, Greg.
Great. Thanks a lot. Thanks for having me.
It's great to have such a legend on the show. So as we were saying in the pre-show, there's a lot of things we could talk about. Mm-hmm. My audience is energy professionals.
Great.
And that includes solar, wind, and batteries, but a majority of solar professionals. And most solar professionals know something about agrivoltaics. It's dual-use solar, right?
Mm-hmm.
We're growing crops. We're grazing sheep. And it's very early days in the U.S. still. We're maybe, a stretch would be 10 years into that journey, right? But tell our listeners a little bit about yourself and how you got interested in agrivoltaics, and then we'll go from there.
Great. Well, I got into agrivoltaics as an ecologist, similar training as you. And really what we were seeing is we were doing a lot of natural ecosystem work in the southwestern U.S., and people kept coming to us asking, do solar panels and solar farms create a heat island effect? And when we were trying to get at why they were learning about this, went and looked at some of the solar installations, and quite a few, especially in the Southwest, the standard practice was to clear off all vegetation, including some of the soils. And being a plant person, I knew that plants did this thing called transpiration, this topic people learned about probably last in high school, that plants lose this water through this natural process. And if you've gotten rid of plants that could produce that natural cooling effect, it actually could make sense that you would consider a solar installation create a heat island effect. But at the same time, they introduced lots of shade, so wouldn't that be a cooling effect? And so it really could go either way, and so you just have to measure it. And so we got some equipment together and started working with some solar companies in the West and monitoring them, and found that within the solar array itself, sometimes you would get this heat island effect where it was warmer inside a solar array than it was even in a natural desert ecosystem.
Wow.
And people don't think about deserts as being a cool place by any means, but the plants being there did some cooling. We thought, why don't we stick some plants back into those solar arrays and use those natural processes? That's when we learned that people around the globe, especially in Saudi Arabia and Israel, were actually thinking about ways of cooling down their solar panels to make them more efficient. And hearing from an ecologist that plants lose water and cool naturally was a different kind of concept. And we just put this need and that learning together, and here we are 15 years later.
Yeah, but so I'm not quite following the importance of the heat island effect, because we need lots of solar no matter what. And if the solar is running cooler, that would be a good thing, right? Mm-hmm. You get more electricity out of the solar,
right?
But then somehow you made this leap into, let's study growing crops under solar.
Absolutely.
And this has been done in Europe and Japan and other parts of Asia for a longer period of time than here in the U.S., just because the industries are more mature in those places and land is more precious. We do swim in real estate here in the United States in a way that is pretty unique. But how did you get so interested in this phenomenon of cropping under solar?
Right. So it stemmed from this idea that you could actually help solar panels in hot environments be more efficient by cooling them down. So we were using that natural transpiration process to drop the panel temperature, which makes it more efficient. So we were seeing that we could increase the efficiency of a site by about 3% just by reintroducing vegetation. And then we wanted to know, well, if you're going to start to design a system based on the vegetation you would have underneath, you needed to start to think about it as a system. So the level of shade that you introduced, which kinds of plants tolerate which levels of shading, and how much water do they lose. And so this is where we came at it originally, is if we were in an environment where you could use a lot of panel cooling, why not start to co-locate solar with the plants that lose lots of water, which is agriculture in the Western U.S. And that's how we really got into it. We could have just as easily gone down a track of pushing for revegetation with native plants, but we came at it thinking about a cooling perspective. Then running into a lot of the farm challenges in the Western U.S., which are around water, we really started to see the potential here. There's lots of places in Arizona especially that are running out of water for irrigation. You hear about the drought, but how does that actually, like, where does the rubber hit the road? Is that, people can't, water their lawns. We're already hitting some of those. But because water use in Arizona is predominantly by agriculturalists, they're the first to receive the cut. So we're talking with farmers who are only getting half as much water as they did a decade ago to do just as much productivity. That puts them in a real pickle. So do they end up, shuttering that farm and, leaving that land available for solar? Or another pathway is to help them use less water to do that same level of productivity. And that's what we're finding Agrivoltaics is doing.
Okay. So it's about water conservation and being able to maintain productive agricultural fields and then getting this dual use.
And helping the panels that are installed do better. Because we're in such a hot environment. Most solar panels are functioning best like in the upper to mid 70s. In terms of temperature, it's 112 right now in Tucson, 118 in Phoenix. And so that is well beyond that optimal point. So panels are underperforming. Anything you can do right now when there's prime demand to help them be a little bit cooler is going to increase their function. And so it really does turn into like that crazy win-win-win. Make the panels more efficient by bringing down their cooling, help them bring shade to the plants that are underneath and around them, so that they get protection from that midday sun, which is so harsh. And we're finding better productivity in terms of yield, and we're actually reducing the amount of water that's needed to do it. So it's crazy that it works.
And so let's talk about the future. So where is this going? What are your interests, and what kind of buy-in, I guess, are you getting from both the agricultural industry and the solar industry?
Yeah, great questions. I think part of what the Department of Energy is starting to ask is, how does this scale? And so thankfully we were able to get one of their awards through the FARMS program, the Foundational Agrivoltaic Research at the Megawatt Scale. It's FED, so it has an acronym. And that's where we're actually seeing, these projects that we were used to be doing at like the 1/8 of an acre scale work when you're talking about megawatts. And so for that project, we're doing 5 acres that are in like current commodity crops. So, peppers, tomatoes, leafy greens. Another megawatt we're going to do in native grasses so that you have the level of forage that could enable for the solar grazing that we see across the rest of the United States. And the last one is to bring in more climate smart crops. There we're talking about things that wouldn't usually be on the radar of most people, but are very common in indigenous cultures and in drylands around the globe. So we're talking about intercropping between rows of solar with rows of prickly pear or agave or peppers, all things that have really high values that are already heat tolerant and don't require the full amount of shade that some of the overhead solar systems have provided. Because you're still giving those plants that are growing in the middle of those rows plenty of shade from that midday sun, because the top of this panel is not meant to shade the bottom of the next row. But that means that you imagine the triangle between the top of that panel and the bottom of the next. That's all free shade where you could be growing plants and, boosting their productivity. The other thing is we get really intermittent rains. You never really know when the rains are going to come. And usually you don't get a lot of rain under the solar panels themselves, but all that rain that is sheeting off. We hear from developers that that is a liability, all the erosion potential from that sheet flow of rain. Why not capture it and grow these plants in that space where you have that overabundance of moisture? So it turns into another lesson we have from urban ecology and urban hydrology of utilize that water and pump it out. Now we're pumping it out with plants in between those rain events. So that water is sheeting off the panels, being captured by the plants, being lost as transpiration, and we're managing some of that erosion potential too.
Wow.
Yeah, it's pretty cool. I think the next stage is you're asking, like, what are we going to do? Now we're starting to see, like, we know the plants work. Like that puzzle piece is fixed. We know that we can work within bigger scales. So the scaling potential up to megawatt plus is there. We know that it works at really small scales. Some of our smaller installations are only like 1 or 2 solar panels. Most of those projects are going into schools. And even with those little classroom projects, you can see better production of those like garden crops under the solar panels of 1 or 2 panels. Just that little bit of shade is making that production go up. So now we're starting to ask the question is, what kind of nutrition are we solving? Are we actually, bringing nutrition to places where agriculture has been displaced and nutrition is lost? Are you changing anything about the quality of the produce that is produced? We've already done the science because a lot of people immediately ask, like, are those panels eroding and getting heavy metals into the ground? No evidence of that. Are those heavy metals getting into the plants? Well, they weren't in the soil in the first place. We're not measuring any of that in the plants. So, are you diluting the flavors? Because some people, especially with peppers, will say a pepper needs to suffer to get that spicy feature. Not finding examples of that. It's sort of bleeding into the social sciences of, will people pay more for those crops? Do they pay less because they think it's coming from an industrial space? And for the most part, we're finding people would pay an upcharge, just like organics, because they see it coming from a more sustainable growing environment. So it's really cool to see all the different avenues that have evolved over the last decade.
Wow, that's really cool. There's a lot more to this than meets the eye, so to speak.
Yeah.
And so I almost don't know what else to ask you. It's a big world. I grew up in New Mexico in Albuquerque, and honestly, one of the things that keeps me from seriously considering moving back to the Southwest is the water problems that the Southwest is having and is going to have. And sure, we're building a lot of solar, okay, but our population is growing, our demand of electricity is growing. Has anyone done kind of a meta-analysis of, okay, if we make these adaptations to the industry, we're going to make some substantive impact on the agroeconomic situation and we're going to be okay?
Yeah.
Or is it still TBD?
Great question. I think it's still TBD, but thankfully, the U.S. Department of Agriculture is recognizing that this could be one solution in terms of land use, so you can kind of bust down that conflict between food versus energy. And the other thing is, when you mention impact, that's another thing we've been really struggling with when people talk about scale and impact, because just as many of our research sites are global in terms of underdeveloped countries. So you can talk about a project that's maybe 100 feet by 50 feet, and that solar installation is now supporting, in terms of benefits and cove benefits, to about 200 different families, because it allows for water pumping in a way that they weren't able to do. And so you're turning non-arable land into arable land for food production. The power is going not only to pumping, but to the schools. And so that is a very small footprint, but it is a very real impact for those folks. And similar, being in New Mexico and in Arizona, there's so many, it's surprising just how many indigenous families are still living without access to water or access to energy, like they're not grid connected.
Right.
And so there's so many opportunities for decentralized projects that are at that smaller scale. When you talk about, like, can you actually, move the needle in terms of saving water? I think all signs are pointing to yes, but that's part of what the farms grant was trying to do, is push people to demonstrate that at the megawatt scale.
Yeah.
I think we can see that the water savings is there, largely because we were cutting back water by 50%, dialing back our irrigation by half in our agrivoltaic settings. And for about 60% of the crops we're trying, everything from broccoli, lettuce, leafy things that would otherwise wilt, beans, peppers, cabbages, bok choy. And for the most part, we could cut back the water by half in an agrivoltaic setting, and you saw no impact in yield. That tells me, one, hot dog, you can cut back water. The other one is you can go farther before you start to impact yield. So one of our projects is to try to design a more precision irrigation system so that as the water is drying out, you trigger the solenoid valve to deliver the water. That will tell us at the end of the year, what's your crop per drop? How much more efficient can we be with our water because of our solar? So now you're changing that narrative from food versus energy to food because of the energy. So for us, I think it more than anything is a policy issue. I think I see all the benefits. I see the potential. I want to do it, but it's very difficult to, one, become a first-time farmer and have access to land. That is a real challenge we're hearing more and more again. And the other one is a lack of community solar laws in a lot of places that don't enable that kind of access to the grid market. That part of that is, I think, the next frontier in terms of where we're pushing this field.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
Yeah. I definitely am thinking a lot now about micro engineering of these water irrigation systems. Mm-hmm. And there's another thing here, though, and that is that plants, even if they're a full sun crop, they don't necessarily want full sun for the full day.
Yeah.
And so that middle of the day shade could be a benefit. Is that?
That's it. You're nailing it. It's almost like you're reading our latest paper that's just coming out.
Okay.
And so in ecology, we call this midday depression. It's kind of like me if I don't have coffee. But plants, they're green all day, but they're not doing their photosynthesis thing all day. Mm-hmm. And remember, photosynthesis is like how they get their carbon to grow and produce, the yield that we want out of a farm. But for the most part, especially right now in, say, June, July, in the Southwest United States, a lot of those plants, the sun comes out, the photosynthesis just takes off. But even by 10:30, 11 in the morning, we've been measuring these plants. We've got a device that can actually measure their photosynthetic rate. It's kind of like when you go to the doctor, they take your pulse and your blood pressure. It's not the full picture, but it gives a good indicator. Photosynthetic rates in these plants are crashing to like the point of zero. Like the plant is basically off from 11 in the morning until 7, 8 o'clock at night. Sometimes you'll get a little blip back there in that golden hour in your sunset. Mm-hmm. But imagine that plants are not functional for 75% of the day because sunlight's in excess when it's really dry or really hot.
Yeah.
And so what does agrivoltaics do? It's doing exactly that, giving the plants a little parasol or a little shield from the sun so they can function longer throughout the day.
Yeah. So you do see that some crops are producing more when they're grown in partial shade.
Absolutely.
Yeah.
And some of those plants, like native to the Southwest kind of region, like imagine a Southwestern diet, talking about beans and rice. Beans in particular, that seems to be a sun-loving plant because it's grown in the sunny environment of the Southwest U.S. But even that plant, giving it some shade from this agrivoltaic setting, we saw a 300% increase in their yield. It's like, wait, what?
Wow.
And even the leafy greens, that one you'd kind of expect, thinking about a leaf that's in the sun, like it has to have water, it's just going to be wilty. I think anybody who's tried to garden has seen wilty plants. Those leafy greens are doing so much better in an agrivoltaic setting that our farmer partner in Colorado, Sprout City Farms, only grows all their leafy greens that they do for their community supported agriculture project in the agrivoltaic setting.
Oh, cool.
Because not only are you're getting a win-win-win there, you're getting the bigger leaves because Some of those leaves can now get larger because they're not stressed. Part of it is maybe it's a little bit too much shade, so they're actually reaching out to try to capture some sunlight. So that's actually greater because now you're making more leaf per plant. The other part is the seasonality. So during the summer, it starts to get hot and dry. That's when your plants went to bolt, like they start to go to flower, and you can taste it. You can taste the leaves being less sweet and more bitter. But because they're not experiencing that stress in the agrivoltaic setting, it's taking longer to get to that earthy, bitter taste. So they're making butter lettuce, in July that otherwise they couldn't do past May. So now they're able to bring something else to market that they couldn't before.
Yeah.
That's the agrivoltaics.
Yeah. I'm curious, is anyone doing this in the Midwest or in like the Central Valley of California, the two major, what I think of as breadbaskets for the U.S.?
Yeah, certainly in California, you're seeing it come on more and more for a few reasons, not only because of that shade benefit that plants can receive, but because of that energy independence. You might hear because of all the wildfires that are happening in the West, sometimes we have this challenge with the big winds blowing through. Sometimes it's because power lines have come down and started a spark. They're shutting off the power during those high wind times.
Yeah.
Imagine you're a farmer who's dependent on that irrigation, which is powered by energy. You're starting to see more on-farm renewable energy needs. Some of the big berry producers that need to do extra refrigeration prior to distribution across the U.S. or into Mexico, they need a lot of renewable energy. And so they're coming at it for some of those different reasons. In the Midwest, there are projects. Quite a few of them are related to sheep grazing. So that form of agrivoltaics, which is producing, wool and meat production. You're starting to see some questions about, can this work for food production there with corn and soybeans? But you're facing different challenges. There, a lot of that equipment is larger, and so you need bigger spacings between the rows. And that bigger spacing between the rows from a solar developer side means less revenue per acre. And so where is that trade-off? If it's more valuable to produce an acre of renewable energy than an acre of soybeans from a purely economic standpoint, you might say, well, pave the Midwest in solar. But that's not what most of us are looking for. That's a massive change in livelihood. That's a massive change in demographics. That's a massive change in just terms of what represents the Midwest. And so finding that balance between economic benefits and community benefits is, I think that's another forefront challenge that we're going to have to address in the U.S.
I mean, the thing is we're really only talking about 2% of the landscape all in,
right.
So it's a relatively trivial amount of the landscape. We've already converted about 6% of the landscape to the built environment, to roads and buildings and bridges, et cetera, right? And so it's not a paving over of the breadbasket. It's an integration of clean energy. And, and we forget too sometimes here in the Midwest, I live in Illinois, 60% of our corn crop is being used for corn to ethanol. Hugely inefficient use of that land. I would rather see, it growing broccoli or something like that.
Right. Well, it is interesting because as our partners at the University of Illinois Urbana-Champaign have been talking with farmers about this, some of them are wondering, we came at it with, can you do agrivoltaics with corn and soybean? Right. Quite a few of them are saying, well, what if we stopped doing that and started producing local food? Yeah. They don't want to be dependent on California for importing food either. And so they're asking us questions about, don't spread out the rows of solar for a corn combine, bring it back to what it would be and let us produce, food for our region.
Yeah. Yeah. Or you could change the equipment. I mean, that's a big shift, but you could make the equipment smaller. But so in terms of those like corn and beans, has anyone really done the research now on like a tracker? And can you grow corn under a tracker?
You can. In fact, we've seen corn growing both under the tracking type system and that elevated structure that we were talking about. And we didn't really think so because corn is in what biology would call a C4 plant. It's evolved to be in a high light environment and not lose too much water. So we thought if it has evolved to be in a high light environment, you probably can't put it in a shady environment, but it worked. It actually did even better in some of those places. In our project all the way in Tanzania, we saw increased corn yield in this agrivoltaics environment. But doing it here at scale, that's right at where the USDA projects are. There's a program called SCAPES. If you just Google SCAPES USDA, you'll find it. And they're looking at exactly this question. If you do spread those solar panels farther out, you almost get less of the agrivoltaics benefits in terms of the shade being cast. But the next question then is, how much heterogeneity do you create in the crops? Do you end up with some crops growing a little bit better because of the shade and ones in between those solar panels doing, average? Or do they do better? And does that actually matter? Is that a level of heterogeneity the farmer can live with? So all of those are like right there in the cutting edge questions.
Cool.
Yeah.
Well, what else should our listeners know about your work, Greg?
I would say more than the science that we're doing is that we're trying to create an international network of sites. When we started this, in 2011, we didn't even know about the French or the Germans who were doing the researchers. We all thought we had come up with it, but we were doing it for very different reasons. As you mentioned, in some of the European countries, they're very space constrained, and they're like, how do I beat both of these needs with my limited resources? Here in the Western U.S., it was about how do we build those synergies between plants needing some respite from the sun, panels needing some cooling potential, farmers needing water. And so what we're trying to do is identify global partners that give us an eye into our future. So for example, we have a partner site in Mexico City, in Morocco, in Kenya, Tanzania, Israel, and we represent the climate future for Kenya, believe it or not. We're quite a bit warmer and a little bit drier. And that's supposed to be like their 50-year projection. But because of these wild swings you see in terms of drought and then floods around the countries, around the globe, the last 2 years have been like Arizona and Kenya. And so we actually have been bringing some of the crops they traditionally grow to Arizona, doing some agrivoltaics trials there, and giving them insights into the potential for their own food system. We can then take what we're doing to Morocco and to Mexico City, which represent our climate futures. And so it's that partnership across the globe that allows us to create kind of an agrivoltaics network. The other thing we keep hearing about is, we're transforming how food and energy could be done across the U.S. So how do we get that training with the next generation? What we're really trying to do there is we're working towards an international school of agrivoltaics. So I'm an ecologist. Our partners are engineers. Some of them are hydrologists. Some of them are farmers. Some of them are ranchers. And so how can we start to train people across the U.S. and across the globe to do this kind of work in different environments and help them have that mobility to go visit other countries or other places, not only to build that like cultural understanding of like, what's it like to be in the Midwest? What's it like to live in Kenya? What's it like in Morocco? Just that global citizen perspective, but also to build off of those unique opportunities to like go spend a week with someone who's really thinking about ranching in this kind of system, and then bringing those lessons back to where you live and seeing how you can apply them.
I love it.
Yeah.
Well, that's all the time we have. I want to thank Greg Barron-Gafford for being with us today from the University of Arizona here at the Solar Farm Summit. I'm Tim Montague. Check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify, and reach out to me on LinkedIn. I love hearing from my listeners. And with that, let's grow agrivoltaics. I'm Tim Montague.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.